Hi, my name is John.
And my name is Alice, and you're watching Math Videos for Parents. We help you so that you can help your kids with math. And John, today we're talking about the volume of a triangular prism. So we're kind of continuing our series on volume and surface area. So when I was learning how to calculate the volume of a triangular prism, first let me just talk about how we even know it's a triangular prism. So basically it's a 3D solid, and you can see this face here is a triangle. And so is the rear face here. So the way I learned it was just to know this formula that volume is the 1/2 base times height times length. And base is the base of the triangle, so it's 4 inches. Height is the height of the triangle, so it's 2 inches. And then the length is kind of the length between the two triangular faces, so it's 10 inches. So I would just plug it in. So I'd say, okay, the volume is going to be 1/2. And my base is 4. My height is 2. Oops. And my length is 10 inches. So 1/2 times 4 is 2. 2 times 2 is 4. 4 times 10 is 40. So my answer is going to be the volume is 40. And I want to make sure to keep my units of measure. It's in inches. That's what we're given. And because it's volume, it's cubic. So it's inches to the 3rd power, or inches cubed. John, how do they teach it now?
So I think the first thing to point out is when it comes to prisms versus pyramids, sometimes there's a misunderstanding between the two because they both have like a triangular portion or like a tip, but when it comes to prisms, there's a base and a height that are there's two separate bases that are parallel to each other, and there's the length, like you were saying, the L that connects the two together. So I want to first point out the wording difference, but to find the volume of any type of three-dimensional prism, we can take the mindset of slicing. So you pointed out the triangles on each end, and we could think of this as a stack of triangles, all of the same size. So this one here that I'm dragging, that was the second one that you traced out, and then I would have another one, right on. Well, I guess, yeah. Imagine it's over it. Maybe we can reorient it, but like imagine they could all. We'll go this way with it. Imagine they all like kind of fit on top of each other, and the collection of all those slices make the solid. And if we look at it that way, that we can fill up a complete solid using one base figure, which in this case was a triangle. If we can fill it all the way back to the end, then we could think of the volume as the collection of all those different base areas, all those different triangles.
Kind of like a stack of crackers.
Exactly.
Triangular crackers.
Exactly. It's a big stack. So with the triangle, any one of these, the area of the triangle is half base times height. And most students know that because that's one of the familiar shapes. So they would just do 1/2 times 4 times 2. And that gives us out 4 for the base. So the base area is 4. And then they want to just expand that along the whole, length. Like I need to make that go 10 inches long as well. So then we just multiply that base area, which we call B, by now they call it H for height, like the height of all those triangles together. So it's a base area of 4 and a big long height connecting the two bases of 10. That would give us our volume, and that's equal to 40 inches cubed.
I see. So if you can remember, base times height, then it's just a matter of saying, okay, what is the area of the base?
Yep.
Which is going to be, now we only have to remember how to calculate like 2D area.
Exactly.
For different shapes. And then we can just say, okay, triangular base, I know area of a triangle, and then I know like the length of my stack of crackers. And it doesn't matter what shape the crackers are, you've always got to multiply by the length of them.
Exactly. And we use capital B when we talk about base area because when we were doing just the triangle, we use lowercase because that's the base of one triangle. But commonly in the math books these days, you'll see a capital B. That's understood to be base area. So I'll just point that out. A little bit different than the B that you used.
Right. Okay. All right. So I'm just gonna make some notes on this, and then I am ready to try another one.
Yeah, and I just want to add one more thing too while I thought of it. The nice thing about this is it works for all types of prisms and also for cylinders. So B could be, you know, that could be the area of a triangle, of a rectangle, of a circle. It's very adaptable. So students had to recall several volume formulas. They can just stick to one thing and then look at the shape of the cracker or whatever it is on the bottom, you know, and find that area in 2D because that's what they're used to.
And we actually did a video on the volume of a cylinder, so we'll put it at the end of this video for people who are interested in that as well.
All right.
Okay, so now we have another triangular prism. And again, kind of the first step is to be able to recognize that it is a triangular prism. So I look at this entire 3D object and I think, okay, what is there two of? What shape is there twice? And we've got two triangles. So it's a triangular prism. So now I think, okay, well, the volume, we're being asked for the volume. So let me write the volume equation we're going to be using. We're saying, okay, the volume, the general formula is uppercase B, base times height, and that's going to apply no matter what shape we're working with. We're working with a triangular prism. I've got two triangles. So my area I have to worry about is the triangle. And the formula for that is 1/2 base times height. So the formula, the area of a triangle is 1/2 base times height. So I'm going to calculate what area I've got here for my triangular faces. So I'm going to just say, okay, that's 1/2. And the base is 8. I'm looking at the triangular face. And the height is 4. So 1/2 times 8 gives me 4. Then multiply it by the 4 that's there, and that's going to give me 16. So that's it. That's the area of my cracker, if you will. Now I've got to figure out the volume overall. So I say, okay, that's the base, which is the triangle. That's my cracker, which we just calculated. Uppercase B was 16. And then I kind of have to extrude it, if you will. I have to figure out, okay, that's one cracker, but I've got a whole
It's a good way to put it.
Sleeve of them.
Yep.
Yeah, so that's going to be 5. So 16 times 5, it's going to give me 80. And this time we're in centimeters. So it's going to be centimeters cubed. John, I really like that. It really lets you kind of think through what you're calculating and why, and kind of get a sense for what you're working with.
Yes, and thinking very far ahead, if students eventually do go to take a calculus course, they always have to think in terms of slices, what they call cross sections when they get older. So I think this is a good, gentle introduction to the fact that we can build up something like this using cross sections that are triangles, like stacking them up like crackers.
Excellent. Now I feel like having some crackers. All right, wonderful. Well, thank you everyone so much for watching. We're Math Videos for Parents. If you found this video helpful, please subscribe to our YouTube channel. It helps other people find us. And we also have a Facebook page at Math Videos for Parents. And please send us your problem requests. We really want to help you help your kids with math. Thank you so much.
Have a great afternoon.